Hello, everybody. Good afternoon. We're going to get started here. For those looking for seats, the chair traffic control can point you more to the edges. So come on up front here to the edges, and there's lots of seats that are available around the room. Thanks for coming to this session. I hope you're all happy and awake and digesting lunch if you got a chance to fight your way into the lunchrooms. This session is 30 serverless architectures in 30 minutes, with the caveat that it's not actually going to be 30 minutes, it's going to be 60 minutes, and it's going to be a little bit more than just 30 serverless architectures. So, slightly kind of funny story about this session here. Originally, this was a chalk talk. So earlier today at 11:30, we did a chalk talk, which is meant to be kind of more of a conversational type of a session. And about 2 weeks ago, they reached out to me and said, Chris, we have a small problem. About 1,000 people have shown interest in your 50-person chalk talk. And they said, we should do 2 of these, don't you think? I thought, well, that will help another 50 people, but there's another 900 plus people that won't be able to get into this session. And so we took the chalk talk, turned it back into a regular breakout session. I added a bunch more content, and we're obviously here in a larger room. Just for context, the number of people in this room is equivalent to about a quarter of the people that attended the first ever reInvent in 2012. So it's awesome to see all of you in here today interested in this session on serverless. My name is Chris Munns. I'm currently the Senior and Lead Developer Advocate for Serverless at AWS. I'm actually part of the Lambda and API Gateway product team based in our New York City office. I've been here at AWS for a little over 5.5 years now in a couple different roles. But I come from more of a sysadmin or DevOps or operational background, if you will. So I've got plenty of physical scars from spending time in data centers doing rack and stack. I've got lots of mental scars from managing Linux servers and stuff like that over the years. But these days, I'm all about serverless. And I think this kind of testament to the number of people in this room here is just how big of a deal serverless is. So why are we here today? So this thing that is serverless, it means a lot of things to a lot of people. Here for us at AWS, it's primarily around products such as Lambda and API Gateway, Step Functions, DynamoDB, and a number of others. And what we see is that serverless technologies are transforming the way that people think about building applications, managing and running infrastructure. That said, people typically only know maybe about just a couple of the use cases that are possible with serverless architectures. And so the idea behind this talk is to give you maybe a little bit more inspiration about what's possible, and then we'll talk a little bit about some of the tooling and stuff that you can use for deploying and managing these serverless applications and architectures. So what is a serverless application? In the world of AWS, it primarily revolves around our good friend here in the middle, Lambda. So today, Lambda, you can build Lambda functions in Node.js, Python, Java, or C#. I would say keep your eyes open to see if this list changes at all later this week. And ideally, we're talking about an event source that invokes that Lambda function, and then whatever it is that that Lambda function might do. Now, we're not going to get too deeply into what it is that you might do with those Lambda functions. It's going to be somewhat inherent based on the architectures that we're talking about here today. But primarily when I'm talking about 30 architectures, what we're talking about is what the event invocation source is that's going to trigger that Lambda function. So we talk about things like changes in data state, requests to endpoints, changes in resource state. And so we'll see across these different types of architectures here that we're about to talk about what's possible. Now, primarily at AWS, we lump these use cases across kind of 6 different categories. So we have web applications, backends, data processing, chatbots, Alexa, and IT automation. Now, many people dip their toes with IT automation and exploring with Lambda. Many of you may not realize if you have an Alexa-based device that when you ask Alexa to do something, fairly often the thing that it does or how it responds to you is actually invoking a Lambda function. By usage, data processing is actually one of the biggest use cases of Lambda today. So people are ingesting and processing billions of records or data points, whether they be from devices or beacon collection or things around the ad tech space. We'll talk about architectures with that as well. And then we're seeing an ever-increasing amount of companies moving from traditional server-based web applications and backends to this serverless model. So lots of exciting things to do, lots of big changes in what serverless means. And again, we'll talk through this here today. Around Lambda today, there exists 3 different kind of invocation models. There's a synchronous or push-based model, which we'll talk about this with API Gateway and others, where effectively you are making a request, you're expecting Lambda to do something, and then respond back to you in a synchronous manner. We also then have asynchronous invocation methods. So methods where you're going to effectively do a fire and forget into a service that's then going to invoke Lambda on your behalf and do whatever business logic it needs to do. And then lastly, we have stream-based invocation models. So methods where you're going to have some sort of streaming data, typically very high velocity, coming in and then being processed inside of Lambda. Now, as part of all of this, and one of the kind of key beneficial aspects of Lambda is kind of the deeply ingrained security model with Lambda. So with Lambda, there's kind of two different aspects of the security model that are inherent in the product itself. You have what are called execution policies, effectively what it is that Lambda is going to do when it's invoked. So what is the product that is going to invoke that function? And then you have function policies used for async and synchronous invocations. Basically, what it is that that function is allowed to do. So security deeply ingrained, a couple different types of invocation models, 6 different major use cases, a whole lot of different products. So with that, let's kind of dive in. And so what I'm going to do here on each slide that I have is have a couple of different architectures. And we'll talk through each of them briefly. And then again, we'll get towards some of the tooling aspects later on. So starting off with some of the most basic ones that we have. So a little kind of historical fact, kind of one of the big ideas that drove Lambda was the idea of attaching compute to storage. For AWS here, we've had customers putting data into S3 for over 10 years now. And what they often want to do is something after that data has been put into S3. And so it's pretty common nowadays where you have an S3 bucket, and as objects are put into that, you're going to invoke a Lambda function, maybe to process a text-based file, to take an image and resize it, to take an image and maybe do something like using AWS recognition against it where you want to identify what's inside of a picture or an image, transcoding, metadata gathering, all sorts of things that you would do here. And so in this case, what happens is S3 is going to directly invoke Lambda with a payload containing information about the bucket and the object. Another pretty common use case is for a number of different services, which we'll talk about here today, is having SNS go and trigger a Lambda function. So SNS, Simple Notification Service, is kind of one of the core messaging services that we have here at AWS. It's used for both kind of, you can think of pub-sub-based models inside of architectures. And it's also used for things like SMS and push-based models in mobile applications. In this case, we're referring more to the pub-sub model of we have a concept of a topic. Data is going to come into that topic potentially from other AWS services or directly via its API. And then those messages are going to be made available to a Lambda function. It will pull them in, process them, and execute them. And then lastly, we have Lambda functions can be invoked directly in their API. So often what I hear from people is they say, I just want a really simple way to invoke a Lambda function. I don't want to have an API gateway. I don't care about authentication and authorization on the client side. Give me a way to just invoke Lambda. Well, we've actually done that from day one, and it's basically just using the API to invoke a function. And so for a number of people, I find that they maybe overthink a little bit some of this, but look towards the API and what you can do directly with the SDKs. You don't have to have another invocation service in front of Lambda if you're controlling the calling service. Next up, we'll talk about Lambda at the edge. So Lambda at the edge, technically part of our CloudFront product or our CDN product. So today around the globe, I believe we have I think over 100 POPs for CloudFront, or near 100 POPs, points of presence that are globally distributed. What Lambda at the edge does is allow you to invoke a Lambda function directly in those edge nodes. This could be really useful for things such as processing headers and cookies that come in from requests, taking a request and figuring out whether it should be shifted to one place or another, taking those requests and maybe mutating or transforming them in some way. And actually now there are people who are having Lambda at the edge directly talk to things like DynamoDB. So you can effectively move your compute of your application all the way to the edge where your clients are for much, much faster response time. Just last week, we increased the amount of memory for Lambda at the edge functions, a number of other capabilities that just came out during the previous week here. Next up is step functions. Step functions is a workflow execution management service. We talk about it being used for managing state machines. And so what we can have is an event that comes into a step function. Step functions can then process the payload of that event, could do things like decision trees, parallelization, retry, catch, and fail, a number of different capabilities that it has, such that you can take the business logic that you would have put inside of your function, or essentially the orchestration logic, and bring that up to the step functions level. And what this saves you is having to write things like, say, retries and failures and catches inside of your Lambda code, letting step functions handle that, so that your Lambda code becomes even more streamlined And effectively, then you're paying less because it should take less time. And you can take a bunch of that business logic and put it up to step functions. So a really useful product in orchestration of multiple Lambda functions or of any sort of more complicated business logic. Talk about a couple of API gateway use cases here. So API gateway, a very flexible and capable product in of its own. So with API gateway, you can have it sitting in front of Lambda, such as when HTTP and HTTPS requests come in, your API gateway is then going to go and invoke those Lambda functions given the permissions and controls that it has. And so with this, we've got customers creating completely serverless API backends. Just a couple weeks ago, we launched something called regional endpoints for API gateway. Previously, we had what were called edge endpoints that were always fronted by CloudFront. Now with regional endpoints, you no longer have CloudFront in front of them. So if you were building, say, a kind of a semi-public, semi-private microservices type of architecture inside of a region, you could save yourself a little bit of latency and having to go out to a CloudFront POP and come back for those requests. And so there's a whole lot of things that you can do with this, and I think this is maybe one of the most exciting areas that we see people today in building applications. Another thing you can do that people don't necessarily know a whole lot of is that you can actually invoke step functions directly from an API gateway request. So if you have some sort of sophisticated or complicated business logic, maybe you're taking a larger request payload and you need to do something more complicated with it, instead of having to go to a Lambda function and then invoke step functions, you can directly invoke step functions from your API gateway. Now, this is more useful in an asynchronous model versus synchronous model. You're typically not going to want to have to go to step functions, have it execute Lambda functions, and then return something as part of the same request. But this is really great, again, in those asynchronous models. And then lastly, you might decide that you don't need Lambda or step functions for your workload at all. And so you could put API Gateway directly in front of a number of AWS services, such as DynamoDB or S3 or Kinesis, and effectively expose the API directly up to the client that's interfacing with it. So this could be really great for mobile applications where you, say, need to give customers access to data that they have in Dynamo, allow them to upload or pull down data from S3. Instead of having to build any sort of interpretation layer with something like Lambda as the middleman, you can, again, just have API Gateway go directly to that and still have access to custom authorizers or things like Cognito user pools, API keys, throttling, and so forth. And so for mobile applications specifically, this is an incredibly useful workload that's very, very powerful. Talk about some of the messaging services use cases that we have. So back a couple lifetimes ago, I used to have to manage outbound email servers. I don't know how many of you have to deal with that or have dealt with that day to day, but there's blacklists and gray lists and reputation that you have to care about. And SES does a good job of helping handle that for you. However, when you're sending a lot of email to customers, you're going to, from time to time, have some sort of bounce back. And so it could be because a customer's mailbox is full, maybe their account no longer exists, maybe they've marked you as spam. And so what you can actually do is take the notifications that SES collects back from that customer's mail service and then immediately process them with Lambda. So this can be really, really useful if you send a lot of email to customers to say, go and flag a customer's account to say, don't send this customer any more email until they log in and maybe say that, yes, this is the right mail to use. Or if you find that you're getting a whole lot of spam requests come back, or a whole lot of bounces come back from, say, like an email campaign, you can actually now in SES, as of, I believe, last week, tell SES to stop sending any email. So even if you were doing a bulk shipment of it, you can, based on, again, logic and Lambda, tell SES, hold on, pause sending all emails until I've gone and resolved whatever the issue might be. Amazon Cognito, which has a couple different capabilities, but is often used as part of user pools, which is a completely managed user authentication and management system, has the ability to trigger Lambda functions as part of various different lifecycle events. So with Cognito user pools, you have the ability to do things such as create an entire customer user registry, including things like profile information, password information, setting up things like multi-factor in a number of different ways. And so as part of Cognito, there's kind of different life cycles that your users can go through. Let's say they want to reset a password or update information about their account or their profile. And based on that, you can actually have Cognito fire off triggers and invoke Lambda functions based on those. So maybe a customer goes and does a password reset. Based on that, you want to send them an email to say, hey, we noticed that you just changed your password. Let's make sure that that was you. You could use Lambda to help with that as a kind of a reactive event as part of that. And then lastly, I've kind of already mentioned how SNS can be used to invoke Lambda functions, but in a kind of slightly more serverful context, as it were. Autoscaling, as part of EC2, has the ability to send notifications due to scale up or scale down events or failures of those happening. So this could be really useful for integrating, say, with a monitoring system or a logging system or some sort of third-party CMDB to let you know that hosts may have come or gone. Maybe you want to remove a host from being able to page your team because it's disappeared. This is one way that you can completely automate that process and apply that logic through Lambda instead of, say, having someone get woken up at 4 a.m. because a host has disappeared. Let's talk about some of the streaming analysis capabilities or use cases with Lambda. So Amazon Kinesis, which now has kind of a number of different components to it. It has streams, it has Firehose, it has analytics, is used for a number of different use cases where you need to do very high throughput ingest of data. So think things like in the ad tech world where you want to do beacon collection or you want to do click tracking on a website. Maybe you're ingesting log information from either your infrastructure or from devices or from whatever it might be. Kinesis can basically scale very, very wide and handle that data coming in. Now, as that data comes in, what you have the ability to do is invoke Lambda functions on a shard-by-shard basis. So what it will do is it will have a single Lambda function invoked per shard. So if you do have some sort of ordering that matters inside of that shard, Lambda will help you, it won't violate any of that ordering. And so what happens in this model, it's slightly different than some of the rest in the streaming models, is that in this case, on the Lambda side, what we do is pull Kinesis for you. So every second, we're pulling Kinesis and potentially executing a Lambda function if there is data in the stream. We'll pull in that data, and then again, whatever it is that you do inside of that will get done. On the other side here, we've got a much more complicated architecture. In this case, what we're doing is we're working with Kinesis Analytics. So what Kinesis Analytics allows you to do is take in data, process it in near real time using just normal SQL queries, and then output that data wherever you need to be. So as of a couple weeks ago, we added capability that you can pre-process that data using Lambda. So my request comes in via a stream or a Firehose. It goes into Kinesis Analytics. I can call Lambda to do some sort of ETL or normalization or combination of data from maybe another data source that I have, pump it back into Kinesis Analytics, execute my SQL query, whatever it might be that I'm doing, and then it's going to get passed back out to a Kinesis stream or Firehose where it could be potentially invoking Lambda again, or going into, say, S3 or Redshift or another service based off of that. And so what's pretty amazing about the second slide here is we take this first really basic architecture, we add several layers to it, and we can do some very, very advanced real-time computation, ETL, et cetera, of data coming in at very, very, very high velocity. Let's hop over to some of the development and management tools that we have here at AWS. So a couple different tools here that we have that have integration with Lambda. The first I'll talk about is AWS Code Pipeline. So Code Pipeline is our continuous delivery service, part of our CI and CD suite. So in Code Pipeline, what you do is you can set up your full application lifecycle from commit all the way out to production deploy. And we've got a number of different built-in services and built-in capabilities that can integrate. But we also give you the ability to directly invoke Lambda as part of the pipeline. So what's pretty awesome about this is that you can do anything. You could run UI testing, which just on Friday in our DevOps blog, we published a blog post about a company moving from a traditional Selenium setup to using Lambda, saved money, got better parallelization. They went from several hours of time for the UI test to just a couple of minutes. And it took them about a day to set up. You could do that. You could do invocation of API testing. You could do stubbing or mocking off of your services. There's all sorts of things that you can do as part of Code Pipeline and Lambda. You could do more basic things like, say, update Jira, send a message to Slack, whatever it is that you want to put into that Lambda function. Next up, we have Code Deploy, which again, in a more serverful-based way today, is used for deploying applications into EC2 or compute, wherever it might be. So you can run Code Deploy on-prem. And inside of Code Deploy, there's kind of this concept of lifecycle triggers around when a deploy to an instance or an application stops, starts, fails, finishes, et cetera. And at any point in that lifecycle, you could invoke a message basically over SNS to kick off Lambda. And so this could be really useful for things like database migrations, interfacing with tools, again, like monitoring, metrics, logging tools, interfacing with things like Jira or whatever you might be doing for tracking your development workflow. And so a number of different possibilities here. And then lastly, Code Commit, which is our hosted source control service, which just last week got pull requests, one of the most requested capabilities in Code Commit. Gives you the ability after a commit, or if there's a time that a branch is created, or if there's a pull request created, to invoke a Lambda function. And so in the pull request model, you could actually invoke a Lambda function to say run a test that tells you whether or not that PR is clean or not. Otherwise, you could say kick off a message to Slack to tell the development team that, hey, there's a new branch. Number of different use cases that can exist here as part of integrating in with your source control. A couple other management tool things that we'll talk about here. So AWS CloudFormation is a template-driven service for deploying resources in AWS. In fact, it's one of the most heavily used infrastructure management tools in the world just based on scale. So with CloudFormation, we have something called a custom resource. And much like it sounds, it's a resource that you define as a Lambda function. And so this can be really useful for going and reaching out to other services that you have, say such as EC2 to tell me, give me the latest AMI for my database. Right? Maybe you run your own database software and you want to find that AMI. Maybe you want to figure out a VPC subnet that is assigned to the dev environment versus staging your production. Instead of hard-coding that information into your template, you can actually use a Lambda function to say, look at tags for these resources for a VPC, and then dynamically pull them into the template and make them available for the resources. So this is a pretty powerful way in automating your infrastructure on AWS. AWS CloudTrail, which is a service used for capturing logging information of API calls to AWS, can regularly take the API call log information that it collects, put that into S3, and then you could very easily process that with Lambda. And so what we see people doing is using this for kind of semi-live auditing of the API calls that are made inside of their account. Maybe you want to flag or check for any time that somebody modifies a security group, or modifies a VPC, or takes a snapshot, or deletes an object. And so there's a lot of different things that CloudTrail can capture, and you want to do some sort of, again, real-time processing or near real-time processing of that event, and so Lambda allows you to do that. Amazon Config, which is a sibling product to CloudTrail, in the sense that while CloudTrail will capture API calls, what Config captures is configuration metadata of resources inside of your account. So let's say I go and add an EBS volume onto an EC2 instance. What Config is going to do is it's going to say, okay, this EC2 resource just changed. There's an EBS volume that was attached to it. And I could see the entire history of this EC2 resource from creation through all the modification that might have happened. I could see all of the related components that might exist to it. And I could process this information as well via an SNS topic message going to a Lambda function. So maybe somebody goes and adds an EBS volume to something, and I wouldn't want that to happen. I could very easily execute a Lambda function, have my logic inside of that Lambda function to process this, and unwind or flag the change. There's actually a better way to do this, though, which is AWS config rules. So config rules, which is part of the config service, is basically, you can think of it as an automated compliance tool. So let's say that you have to meet certain compliance inside your organization, HIPAA, PCI, anything that you have to do internally from a maybe internal business regulatory standpoint. You can define inside of config rules various rules that you need to meet. So with things like PCI and HIPAA, encryption is very important. You need encrypted EBS volumes, encrypted EC2 hosts, certain subnets that you want to use for this. You can actually create those rules inside a config rule, and then basically when those rules are tripped, a Lambda function can be executed. And so this can be a really easy way to do, say, auto remediation. So somebody launches a host, they configure it wrong, but it's in, say, a secure subnet. You can actually have Lambda go and terminate that host for you, or maybe shoot an email out to somebody else on the team and let them know of it. CloudWatch Events, which is part of the overall kind of CloudWatch family of services that we have, is effectively, you can think of it as like an event bus for AWS events of all different sorts and types. So actually, a lot of the things that I've talked about already will show up in CloudWatch Events in kind of a somewhat more standardized way. And so what you can do with these then is directly invoke Lambda functions as part of that, again, for compliance reasons or auditability reasons or auto response reasons. And everything from auto scaling events through modification events of certain services through various different events that are kicked off from like our database services can show up in CloudWatch Events. There's another part of CloudWatch Events, which is CloudWatch Events that are time-based or scheduled. And so effectively, this is managed cron. So for those of you who have cron jobs and have probably dealt with things like making cron jobs highly available and making sure that you don't have two of them running at the same time or all the different issues that come with that, CloudWatch Events is a great way to help replace this. And in this case, basically, you schedule a Lambda function to execute, and what you do in that Lambda function could be pretty much anything. So lots of different possibilities here as well. Two other components of CloudWatch that can interface with Lambda. The first is CloudWatch Alarms. So when an alarm is breached, let's say, high CPU on something, or maybe more requests or less requests than you were expecting, that alarm could invoke a Lambda function, again, maybe to let the team know maybe you need to do some sort of manual auto-scaling on some sort of a service or tweak some sort of other parameter somewhere. You could use Lambda to help kick that off. And then with CloudWatch logs, what it can do is actually, as logs are sent into the service, you can have them then sent on to a Lambda function for, again, near real-time processing, maybe to check for any sort of bad log information that's coming in or a log message that states that something bad happened. Or what we often see people do is take this, pull it into Lambda, and send it off to, say, a database or a data warehouse or something else for later processing or ingest of that record. Talk about a number of database use cases here. So with DynamoDB, we have what are called DynamoDB streams. It's actually based on top of Kinesis streams. And in this case, works very similar to how Kinesis streams work. As inserts, updates, and deletes happen into DynamoDB, it puts an event on the stream, and then eventually that can be processed by a Lambda function. Now this can be really useful for doing things like creating backups and replicas of a DynamoDB table, potentially, let's say, in another region. People will do it to create effectively a more or less an update log for DynamoDB. So maybe you want to be able to do slightly point-in-time recovery of a DynamoDB database. You can take this data, pull into Kinesis, and potentially send it into Lambda, send it into S3 for storage. Other times, people will take data from DynamoDB and put it into, say, Redshift. So they could do data warehouse analysis on top of the data that's also in their DynamoDB table without having to do some sort of bulk copy and insert into the database later on. Amazon Aurora MySQL has the ability to invoke Lambda as a stored function or stored procedure. So we've gone kind of here and reinvented the stored procedures of old, as it were, but at a much higher and much greater velocity, potentially. So customers are using this, again, where they need to do some sort of compute work based upon data, either updated, deleted, or inserted to a database, where they don't want to have that work done on the compute of the database itself. This can be very useful, again, at very high velocities or very high traffic databases where stored procedures traditionally have become a pain point in terms of taking up CPU resources from the other capabilities of the database. And so you can take this and completely offshoot it off to Lambda for whatever your need might be. And then lastly, Amazon Redshift, our data warehouse, has a number of different ways that it creates events. When you create replicas, when you do snapshots, when you do backups, you can create an event that can go messaged out to SNS, which can invoke Lambda. So this can be useful for things like region copies. This can be useful for things like creating multiple copies of Redshift clusters, responding to failures, responding to incidents, et cetera. A number of different kind of automative capabilities that you can do here. So next we'll talk about some of the AI services that we have that sit around Lambda. So the first here is Amazon Lex. So Amazon Lex is a natural language service that's used for things like chatbots, whether they be text-based, voice-based, et cetera. And basically what happens is when you are conversing with that chatbot, at some point it has to do what's called a fulfillment. This is basically execute the business logic of what this chatbot is looking to do. And in many cases, or at least with Lex, it's going to be Lambda behind the scenes. So if I have a chatbot that I'm using to order pizza, at some point I have filled all of the slots of that conversation. I want a pepperoni pizza, a large, this is where I live, delivery, et cetera. And then it's going to pass that information onto a Lambda function to do whatever the execution is of that conversation. Now this is extended further into Alexa. So for those of you who have Alexa devices at home, again, a lot of the times that you ask Alexa to do something, it's actually going to invoke a Lambda function behind the scenes. And this is based on Alexa being built on top of Lex. And so if you've ever created a custom skill for Alexa, it actually will show you directly how you can interface this with Lambda. And again, many of the, what was 25,000 skills a couple weeks ago are actually backed by Lambda. And then lastly, AWS IoT, which is of itself kind of a whole ecosystem of capabilities. This probably would have looked like 30 serverless architectures plus 50 IoT architectures if I included all of them. But what AWS IoT does is it gives you the ability to invoke Lambda functions based on events from your devices and data ingest from your devices, a number of different capabilities. This also includes AWS Greengrass, which is actually a compute environment integrated with IoT and Lambda that allows you to run Lambda functions on devices itself. So a whole lot of capabilities around the IoT space, and I encourage you to check out some of the sessions this week on IoT to talk about it. So we've gone through the 30 serverless architectures. We're at exactly almost 30 minutes. So the first half of the title of the talk has been kept true. Let's dive into some of the tooling and other things that exist around this world of serverless. So let's talk a little bit here about deploying your applications. So here at AWS, we have our lovely serverless mascot. This is Sam. You will see Sam the squirrel in a number of different costumes and outfits. We've got Sam with nerd glasses. We've got Sam with a baseball cap. We've got Sam with a hard hat. And you might see some of the people on my team who lost bets wearing a squirrel costume this week running around. Just say hi, Sam, to them and try to get a selfie if you can. So what SAM actually stands for is Serverless Application Models. This is a tool that we actually released last year right before reInvent. And we've continued to kind of expand upon it over the last 12 months. And today what SAM is it's an extension for CloudFormation optimized for serverless. So what does that mean? What it means basically is we created certain capabilities inside of CloudFormation specialized for serverless, which basically streamline the work involved in you launching serverless applications. And there are 3 resource types today: functions, APIs, and tables. However, because it's just an extension of CloudFormation, it supports anything that CloudFormation would itself support. And you can also find all the documentation, a number of examples for this on GitHub as part of an open source repository that we have. So this is an example of a SAM template. It's really pretty straightforward. I won't expect you to read every line on this, but what I do want you to get is that there's effectively 3 parts to it. The first part is headers. And what you'll see here on the second line, if you can read it from where you're looking, is a line called transform. So inside of CloudFormation, we have a concept called transforms. These are extension models inside of CloudFormation. This one is for serverless. And so what you need is this line. And what this line does is it tells CloudFormation, this is a SAM template, look for SAM resources. We then have 2 resources in this template. The first is a serverless function. And then we see a number of different capabilities here that align with Lambda. We see down here an event source. Talk about this here in a moment. And then down at the bottom here, we have another resource called list table. It's of type simple table. This is actually a DynamoDB table that will start with just the basic 5 read and 5 write units. And today, since you can enable auto-scaling for DynamoDB, you no longer have to pay attention to necessarily what the read and write units are that you configure Dynamo for. To give you another idea of visualization of this, we have an example in a repo. And basically, this is a screenshot from GitHub, from roughly lines 9 or so to 25, what this actually does is it extrapolates out and creates these 6 different resources on the side here. So what SAM is going to do is it's going to say, you define a Lambda function and an event source. What it's going to do is it's going to create that Lambda function, potentially create that event source, integrate them with IAM the way that's necessary, such that you don't have to think about all of the rules and rights and stuff that IAM is going to require, and again, in a greatly, greatly simplified way. If we were to take these roughly 16 or so lines of SAM template and do them in just raw CloudFormation, it would actually be about almost 80 lines of CloudFormation. So this really, really simplifies the way that you need to write these templates for launching applications. So I mentioned that there are effectively 3 special types of resources inside of SAM templates for CloudFormation: function, API, and simple table. We can see here with the definition for a function that basically we're defining a whole bunch of the things that exist in a Lambda function. So we're defining where the code lives, we're defining the runtime or the language that's being used, where the handler is, the in-memory that we need, the timeout, et cetera. You don't need to fill all of these in, but we do give you basically the ability to. And then down at the bottom here, we have the events section. So this is going to correlate with what the invoking service is for this Lambda function. Now, there are a number of different third-party frameworks that exist for the Lambda space today. However, many of them are specific to a certain use case. So there's a number of third-party frameworks that are specific to API workloads, a couple to data streaming workloads. SAM is basically completely agnostic to all of that. Doesn't care about your language, doesn't care about your use case. It's really just an infrastructure management tool at the end of the day. So when it comes to the events, what we have basically then is deeper support for how you can configure the events along with SAM. So we talked again just before here about the 30 different use cases that we brought up, and you'll find that across almost all of them, not all of them, almost all of them, are supported directly in SAM today. For those that aren't, you can still define the policy that would allow those services to invoke Lambda as necessary. So S3 and SNS, which covers some of the big areas, Kinesis and DynamoDB, API, which represents API Gateway, CloudWatch scheduled events, regular CloudWatch events, IoT rules, and Alexa skills. And so again, across these, it's going to basically set up the permissioning necessary between the function policy and the execution policy so that you don't have to know what that looks like. Serverless API is pretty simplistic today. Allows you to specify some information about a stage, such as if there's caching enabled, if so, how big of a cluster, if you're going to define the Swagger template for your API gateway separately, as well as pass in variables. And then lastly, simple table, again, is a very simplistic representation of a DynamoDB table. The primary key can be defined, and then the amount of read and write capacity along with it. Now, SAM being an extension on top of CloudFormation, the way that it works with building and deploying these is we basically added 2 commands to CloudFormation. The first is package. What package is going to basically do, as it shows here, is it's going to create a zip file with all of your resources for your application. It's going to put that up into S3, and then it's going to come back with the code URI that you need for the Lambda function to know where your code lives. And then the deploy command is then actually going to execute your SAM template with the passed-in code URI information, which is then going to go ahead and tell CloudFormation basically to stand up your serverless application. So pretty straightforward. You can do this all from the CLI in a, again, pretty easy way. Now, just this past summer, we announced something called SAM Local. SAM Local is actually, as it sounds, a local tool for building and developing serverless applications. So what this does is it looks at a SAM template file inside of your code repository. It looks at your code, and what it does is it creates a running container using Docker on your laptop or your workstation, whatever it is that you're developing on, such that you can test APIs locally as well as invoke a function like as if it was another service. So you have the ability to pass in, say, mock JSON data for Kinesis or Dynamo or S3 or SNS against that function running locally. No need for internet access or anything like that. And so this is a great tool for being able to build and test your Lambda functions. And actually, I should mention here, this is a completely open source tool. It's written in Go. We are actively taking pull requests from the community for it. My apologies, the URL is a little hard to see here at the bottom, but it's github.com/AWS-labs/AWS-SAM-local. So definitely encourage you to check it out if you're building Lambda-based applications. So you can take all of this and you can put it together eventually into a full formal deployment pipeline. I have another session on Friday about building CI and CD pipelines for serverless applications, as well as in the DevOps track this week. There's a whole bunch of different talks about the CI and CD tools, code pipeline, code commit, code build, code deploy, et cetera. But basically the most basic kind of pipeline that you would see for a production use case looks a little bit like this. So what we have are what are called 5 different stages, kind of the 5 individual separated boxes here. We have a source stage, which is going to be tied back to where my source code lives. We have a build stage, which in this case is using code build to potentially build, compile, do unit tests and stuff like that. And then we have 3 different what I call environmental stages. So testing, staging, and production, whatever you might want to call those. And this is basically a pipeline that would follow all of the best practices that we would recommend at a most basic level. There was a joke I saw one day, and it said, many people have testing environments. Some are lucky to have them that aren't production. And so one of the great things about serverless applications is that a testing environment, when it's not in use, should cost you absolutely nothing. If you were to think about in a traditional compute environment, that is not likely to be the case. So again, one of the key differentiators here of serverless is the idea that you don't pay for idle. And so very useful here. So another thing I like to say is that you can't move fast if you can't measure what's going on. And so monitoring, logging, measurement of applications is incredibly important across the board. This is not unique just to serverless. But what we have inside of serverless today, in terms of the services, Lambda, API Gateway, et cetera, is pretty deep integration with CloudWatch Logs, CloudWatch Metrics, et cetera. In CloudWatch Metrics, we have today 6 built-in metrics for Lambda, 7 built-in ones for API Gateway, everything from invocation count, duration, throttles, iterator age for things like the stream-based workloads, the DLQ size, which we'll talk about this here in a moment. API Gateway has API counts, latency, both from the integration source and itself, 400s, 500s, and so forth. And so you can take these graphs as you see them in the console, and they're pretty straightforward in terms of what you see here. So here are the basic graphs that are enabled for this. Now, logging is also built directly into both of these products. And so inside of API Gateway, we have 2 different types of log levels. We have error and info. You can tweak that on a per stage basis. You can also potentially log the full method or body content of a request. Now, you want to be cautious about doing this because you're paying for the data that goes into CloudWatch logs. And so this could become quite a lot of data if you have a very active API. It's very useful for troubleshooting and debugging of issues that happen. Lambda also captures logs for you. So inside of a Lambda function, anytime that you do the equivalent of, say, a console.log or a print.f statement that would output any sort of text from a function, we're actually going to capture that into CloudWatch logs and make it available for you. So being able to put in debug statements or actual true application logging, you don't need to do anything complex. You don't need to install a library. You don't need to install any tooling. Just output that log data, and it will be captured on the Lambda environment and, again, sent to CloudWatch logs. And then there's a number of different cool things that you can do with CloudWatch logs that I think people aren't too familiar with. One is called log pivots. And this is basically the ability to regex a certain part of a log line, pull data out of it, and then generate a metric from that. And so you can very easily have kind of a multi-purpose log line. You could have your log line that has a data point, take that data point, create a graph from it, take that metric graph and create an alarm around it, and have, again, a number of different sources of information to help make it easier from an operational perspective. We also have the ability for you to very easily export these logs to Elasticsearch, or S3, this should say. So being able to view that data with, say, Kibana or things like Athena and QuickSight is really, really powerful. And so again, these are two things that are very, very useful. Another thing in this space is just last week we launched the ability in API Gateway for custom access logging. And so what we now do is give you the ability to customize the log format based on your needs. We have a couple of kind of built-in buttons here for traditional Apache CFL logs, JSON, XML, or even CSV log formats if that's something that is what you would want to do. And so I encourage you to take a look at this, get a lot more information about your logs, and customize them as necessary for when they get ingested. Another thing that you should take a look at is in CloudWatch, we have something that launched actually a number of months ago now, CloudWatch dashboards. And so inside of CloudWatch, what I have here is I just mocked up a very basic dashboard for a serverless application that's Lambda and API Gateway based. So the top group of graphs are all Lambda graphs. Then I have basically some information about my integration latency and latency of my API Gateway. And then down on the bottom, I have things here like errors and counts and stuff. And so really easy to get started with this. Creating a dashboard like this takes just a couple of minutes of clicking around in the dashboard. You can then share that URL with other people inside of your organization. And again, very easily get quite a lot of visibility into your serverless applications. Now, another part of this, so we've got monitoring, we've got logging, is the ability to profile your applications. And so last year at re:Invent, we announced X-Ray. X-Ray is a profiling tracing service that we have. And basically what it does is it captures requests from your application, records all of them, and then makes them available via both a service map and the ability to kind of visualize them as they happen. And so this can be really useful in distributed applications where you have Lambda functions calling other services, calling other Lambda functions, and so forth, and being able to kind of piece together the full map of your application workflow. Tooling it is really easy to get started. And so inside of Lambda, you can flag on the ability to capture X-ray information. That's considered a passive mode. It will capture certain information, but it won't necessarily capture all of the requests made inside of your function. Now, if you want to capture the data inside of your function, you need to include the SDKs for X-ray inside of it. So the very top line of this here, we see a require for the X-ray SDK core. And then the second line of this, I'm wrapping the AWS SDK with the X-ray SDK. And basically what this means is that any calls to AWS services are going to be captured by X-ray and populated inside of the X-ray service. I don't have to do anything else with my code at all in order to capture this information. So really, really trivial and easy to get started. And then we see here the most basic of service maps as part of this. So the first circle that you see here is the Lambda service itself. It's going to invoke a function. That function is calling S3. The green circle here is good. You also can see red and yellow based on certain types of failures that might be happening with the service that you're talking to based on HTTP or HTTPS response codes. We see timing, we see requests per second, a whole lot of information. Now this is a very, very basic diagram for this. It could obviously have a lot more circles based on the complexity of your application. And then if we were to dive into an individual request, we would see a timeline. And now this timeline is very, very valuable for looking into what it is that your function is doing at any point in time. When I talk to a lot of customers where they say, hey, I'm trying to figure out what's going on with Lambda, my function seems slow, things aren't working the way I want, enable X-ray and you will right away gather a whole world of information that you don't have without it. And so we see here how long it took for the service to basically start up, invoke itself, talk to S3, get the response, and complete. And so again, in a much more sophisticated application, there'd be a lot more here. But this is incredibly valuable information in terms of debugging what's inside your application. So again, when people come to me and they say, I'm struggling to figure something out, something just doesn't seem right, they may be questioning Lambda. What I basically want to do is ask them or tell them to do 3 things. One is turn on X-ray. Now, you have the ability to turn on X-ray and control the rate at which it's capturing information and easily turn it off again inside of the function configuration. So go ahead and turn it on when you're trying to figure things out. Let it gather its information. Turn it off when things seem OK. That's totally fine. The other is not to underestimate the capabilities in logging. So again, we don't require you to install logging agents or do anything with your code. Just a very basic output statement from whatever the language is that you're using in Lambda is enough for us to capture that in CloudWatch logs and make it available to you. And there's all sorts of things that you could capture that are application specific that you might want to look at. And then lastly, the most valuable metrics that you're ever going to generate are the ones related to your customer. So inside of your application, creating metrics or creating log lines that are more about application data and business relevant information can be really useful to you. I'll give you an example of this. I had a customer that was ingesting data with Kinesis to Lambda. It was basically an ad tech use case. They had a whole lot of data that was coming in very quickly. They had an ingest layer that was using the Kinesis library to put data into Kinesis. And the Kinesis library will batch up information for you. That information then goes into Kinesis and then was invoking a Lambda function. That Lambda function will pull data out in batches as well. So it's pulling in batches of batches. And then what they were doing is taking the batches of batches, unbatching them, and processing each record individually against another backend service. From time to time, they were seeing failures in their Lambda functions. They couldn't really figure out what was going on. And so we started diving into this, and I started saying to them, well, how many records are you maybe processing at any point in time? And they didn't really have a good grasp on this at all. And then what we did is I said, OK, let's create a log line that shows the number of unbatched requests that you are processing at any point in time. Let's throw that into CloudWatch logs. Let's turn that via a log pivot into a metric. And let's see if we can correlate the graph with the failures that are happening. Sure enough, we were able to. We were able to figure out that they didn't have enough memory for their function based on the maximum amount of records they might consume. And so the reaction to it was increase the sharding, increase the memory, and away went their issues. So again, they were thinking it was something with the platform, it was something with the language. It was actually much easier to troubleshoot by just turning on some logging. The last thing I'll talk about here in relation to this is this concept called dead letter queues. And I don't know, I use a MacBook. This is on a PC. It didn't render it very well. It was supposed to just be a skull and a mail thing and then a queue. I don't know what those other boxes are there. But basically, dead letter queues are a capability of Lambda for async use cases. So things like SNS, S3, SES, a number of other services where basically, if on a certain number of failures of the service itself or of your logic, it will take the message that was going to Lambda, the invocation data, and it will put it into either an SNS topic or an SQS queue, such that you can process it later. Now, I've seen this be very useful in a number of instances. Let's say that your Lambda function is calling potentially another service, or your Lambda function has some sort of business logic inside of it that could fail based on a third party. What you can actually have is after that Lambda function has failed so many times, those requests can go to the dead letter queue and then be processed later on. And so this could be really useful for making sure that you're not losing data or dropping requests. And I basically encourage people to just turn this on. If things are working, it should never get used. But when things don't work, it gets used, and it can really save you, a lot of headache and a lot of pain. So dead letter queues, really useful. Turn them on however you can, and keep them on. So with that, we've talked about quite a lot today. We've talked about, again, kind of 30 different architectures for invoking and using Lambda, everything from web application backends to kind of full streaming analytics processing pipelines to very basic things like processing email bounce requests to doing things with our development and management tools that are very, very simple little, probably a couple of lines of code type things. Think again about kind of the 6 main different use case buckets that exist for Lambda. Web applications, backends, data processing, chatbots, Alexa, IT automation. You're probably not going to do something in all of those, but there are a couple that are going to be very important to you. 3 different types of invocation models, right? Synchronous, asynchronous, stream processing that then go back and align with the various different services that integrate. And so when you put all this together, what you get is a lot of different use cases for how serverless can be impactful for your business. Everything from replacing hosts that are running cron up through potentially huge fleets of hosts. Earlier today, I ran into a customer in the hallway, told me about how his Lambda and API gateway setup did about 8 billion requests last month. It's going to do 10 billion requests this month and probably more next month. And these are the kind of stories that we're hearing every day in this space, and so it's very, very, very exciting. Take a look at SAM for deploying your serverless applications. Take a look at SAM Local for developing them local on your workstation. Keep your eyes and ears open for some more interesting news this week in that space. I didn't talk about it, but you can get started in this space using the AWS CodeStar product. This is basically a tool that allows you to glue together a number of our development CI and CD tools. And so you can very easily get to a strong kind of development pipeline put in place without having to do a lot of work. Almost everything I talked about here today could be found on the serverless landing page. So AWS at amazon.com/serverless, reference architectures, how-to guides, documentation, videos, links to our blog, which is incredibly active, partner solutions, all sorts of things that exist here. My name is Chris Munns again. I am the lead developer advocate for serverless at AWS. You can find me at munns@amazon.com. You can also find me at Chris Munns on Twitter. I would love feedback on this session, and so please do provide it. I'd love to know what I can do better next time. Again, this was 30 serverless architectures in 30 minutes, the extended version. Thank you all for coming. Thank you for those who put up with the line earlier.